Let's do one example using distance vector routing. Suppose there are 4 nodes A, B, C and D, and I want to apply distance vector routing algorithm. So initially every of the node will be having its own distance vector. So let me make a distance vector for every of the vector. So here I will be having 4 entries A, B, C and D, and here also I will be having 4 entries A, B, C and D, A, B, C, D, A, B, C and D. Here also I will be having 4 entries A, B, C, D, right? Now D to D distance is 0, C to C distance is 0, B to B distance is 0 and A to A distance is 0. Initially I will say that A can reach to D via 7, to B via 1, to C via 3. B will say that B can reach to A via 1 and C via 1 and D via infinity. This is the initial cost, right? Now C will say that to A it will take 3, to B it will take 1, to C obviously it will take 0, to D it will take 2. Now D will say that to A it will take 7, to B it will take infinity, to C it will take 2 and to D it will take 0. So these are the initial vectors. Now let's see what happens after an exchange. So at A we will be getting 3 vectors from B, from D and from C. So this is the vector that we will be getting from B, this is the vector that we will be getting from C, this is the vector that we will be getting from D, and finally I will be computing one vector for D, for A. So let me basically copy this because I will be using this vector again and again. So let me just copy it, or maybe let me copy after making the partition. So I will be getting these vectors. Now let's just copy it so that I can just paste it whenever required. Now at A I am getting these 3 vectors, and it will say that this is A, B, C, D. It will say like the first vector is I'm getting, let's say, from B, and then from C, then from D. So this B vector will be just 1 0 1 infinity, 1 0 1 infinity. C vector will be 3 1 0 2, 3 1 0 2. D vector will be 7 infinity 2 0, 7 infinity 2 0. And then A will do what? A will just compare whichever is minimum. So A to A is obviously 0. So first it is 0. Now A will just compare whichever is minimum. So let me write the cost here. A to B is 1, this one, and A to C is 3, A to D is 7. So it will add this one in the whole vector. So this is 1, this is 4, this is infinity. So obviously 1 is minimum. Again this is 2, this is 3, this is 9. So 2 is minimum, infinity 5 and 7. So 5 is minimum. Now A vector will be 0 1 2 5, right? Now A vector will get updated to 0 1 2 5. Now at B also I will be getting vectors from A and vectors from C. So let me just paste this and let me erase one of them. So at B I will be getting 2 vectors, one vector from A and one vector from C. Now one thing is to note here is that A vector has been updated. So should I be using the updated value or should I be using the old value? Now like in general what happens, that generally the exchange happens simultaneously, which means it is not like the case that A will update its vector and then this updated vector will get propagated to B. I mean, like this will happen, but in the next round. So basically, currently, whenever A has sent a vector to B, which means whenever, or B has sent a vector to A. So whenever B has sent this vector, like this vector to A, then at that time only we must have whenever B has sent a vector to A, which means this vector that 2 has got sent to A. Now A must also have sent its own vector, which is 0 1 3 7 to B. So basically this exchange happens most of the time simultaneously. So otherwise, like it will be given in the question. So what is the stage? Like if you take the updated vector, there also no problem. I mean, if they just require the final result, then if you can take also updated vector. If you're taking old vector, then also no problem. But if they require some intermediate result, maybe they say that what will happen after one iteration, then they will define what is an iteration, how the exchange are going to happen. Should you be using the old vector or should you be using the new vector? So they will define everything. But if you are just interested in the final result, then you can take updated value or you can take old value. So I'm just taking old value. I'm going step by step. So I will always be taking the old values. So this is just one iteration. So I will be taking the old values. So from A I will be getting this vector. From C I will be getting this vector. And from B to A I have one distance. From B to C I have one distance. Now let me take the minimum. So I will be taking the minimum. First I will be just doing 0 here, because from B to B it is 0. Then you just take the minimum among 1 and 4, it will be 1, because 0 plus 1 is 1 and 3 plus 1 is 4, and this is 4 and 1, so again 1. This is 8 and 3, so again 3, right? So 1 0 1 3, this is the vector that I will be getting at B. Now what about C? At C I will be getting again 3 vectors from A, B and D. So let me go to the next page. At C I will be getting these 3 vectors, right? So at C, this vector is from A, let's suppose this is from B, this is from D, and then I will be computing a vector for C. Now obviously from C to C it is 0, so first write this 0 and then just compute the vector. So let me just write it. From A I will be getting the vector 0 1 3 7. From A I will be getting vector 0 1 3 7. From B I will be getting vector that is 1 0 1 infinity. Like the B vector has been updated, but I am not taking the updated value. Okay, 1 0 1 infinity, I am taking the old values. This is 1 0 1 infinity, and then at D I will be getting this vector which is 7 infinity 2 0, which is 7 infinity 2 0. Now the distance to A is 3, to B is 1, and then this is 2, 3 1 and 2. So just take the minimum among all. It is 3, it is 2, it is 9, so 2 is minimum, and this is 4, this is 1, this is infinity, so 4 and 1, so 1 is minimum, and then this is 10, this is 2, so 2 is minimum. Now the vector at C has been updated to 2102. That is okay. Now let's calculate the vector at D. So at D I will be getting how many vectors? I think 2 vectors I will be getting at D. So 2 vectors from, one vector from C, one vector from A. So from A I will be getting one vector, and from C I will be getting one vector, and this is the updated vector for D. Okay, so from A I will be getting 0 1 3 7. From A I will be getting 0 1 3 7. From C I will be getting 3 1 0 2, 3 1 0 2. So I'm not taking the updated values. Okay, and I'm now calculating the updated value for D. So distance from A to D is 7. This is 7, this is 2. Now let's take the minimum, but before that let me write 0 here. So if you take the minimum between 7 and 5, so 5 is minimum. If you take the minimum between 8 and 3, then 3 is minimum. 10 and 2, 2 is minimum, right? So 5 3 2 0. This is the distance vector that got updated at D. Now what is happening here? I mean, this is, let's suppose this is one iteration, and after one iteration we have updated the vectors. So what is happening here is that in first iteration or at the initial, I am just saying that I do not know the future, which means I just know the immediate neighbors. So we knows that the immediate neighbor is A and C, so it knows the distance that is just one edge away. So using at max one edge, at most using one edges, you can from B you can go to either A using distance of 1, or to C using distance of 1, or using or to D using distance of infinity. So this vector is telling with at most edges one edges. Now after one iteration, what will happen? You are just exploring one more, like one hopes, right? So this information you are exploring. So basically now these vectors, like these vectors are basically telling me that if you use at most two edges, then you can go to, like from A you can if you see here, see these values got changes, right? So from A you can go to C in just a distance of 2. From A you can go to C in just a distance of 2. See here, using, if you just use two edges, at most two edges, right? So if you use two edges, then you can at most two edges, which means it is not compulsory to use two edges. You can at most you can use two edges. After just one iteration you are having these values, right? So this is just like a Bellman-Ford. In Bellman-Ford, if you remember, we need to run the algorithm for n minus 1 times. Similarly, here also we need to run the algorithm for n minus 1 times. So this is basically this is 4 nodes. Then you need to run the iteration. You need to run the algorithm for 3 times, right? Which means now till now you know the distances using two edges. So basically you know the distances, these distances are using two edges. Now here you just need to run this this algorithm one more time, and after that you will be having the distances using 3 edges, and that's where you can stop. Basically you can just run it for one more time. right? So basically I'm considering this as one time, which means that that this 0137 initial representation I'm considering as one time. Then after one round of iteration you are getting this, so I'm considering it two times. Now till now we have done two times, now you just need to do it one more time. So basically you do not need to remember these things, I mean, till how many times you need to run on these things, but I'm just giving you an idea. See, after this, like initially you are just having information about one edge, now you have information about two edge, now you just need to have information about at most three edges. Why? Because the shortest path cannot contain more than three edges, right? The shortest path can never contain more than n minus 1 edges if there are n nodes, because otherwise it will be a loop. So shortest paths cannot contain more than three edges. That's why you just need to run this one more time. So let's just run this one more time. So I have got the updated values, and now let me just run it one more time. So at a, now, or let me do what, let me just copy this, and let's just paste this in the next page here, maybe, or maybe, no, let me just paste it in the completely new page, maybe here. So the vector at a that I have currently after after this round, which is this 0125, right? So let me just write this vector here. So now I have 0125, and similarly at b I have some vector, at c I have some vector, and d I have some vector, right? So I have updated vectors for every of the node. Yeah. So at b I have the values which are 1013. These values are 1013. At c I have the values which are 2102, 2102. At d I have the values which are 5320. So these values are 5320, right? Now let's run it one more time. So at a I will be getting three vectors again. So at a I will be getting vectors from b, c, and d. So let me just copy this template. So at a I will be getting these three vectors from b, c, and d. From b I will be getting 1013. From c I will be getting 2102, 2102. From d I will be getting 5320, 5320. And now if I update the values, then you will just say take the minimum. So if you take the minimum between 2, 5, and okay, initially this is 0, then take the minimum. So it will be 1, 4, and 10. So 1 is minimum, then 2, 3, and 9, then 2 is minimum, and then 4, 5, and 7, then 4 is minimum, right? So at a I have updated the values, which is 0124, and earlier values were 0125. So see, this 5 got updated. Why? Because if you want to reach to d, then using at most 3 edges you can take this path, and then the cost will be just 4, 1, 1, and then 2, then the cost will be just 4. So anyway, at a this is the vector, final vector that we are getting. Now what about b? At b I will be taking, like, at b I will be getting the vectors from a and c. So these are the two vectors, let me not write here, these are the two vectors that I will be getting. Then I just need to take the minimum. So let's take the minimum directly instead of copying these two vectors here. So let me just write these values, this is 1 and this is 1. So 1 and 1. So if I add 1 to the whole vector, 1 to the whole vector, then it will be basically 1 and 3. So minimum is 1, and then 3 and 1, the minimum is 1, and then 3 and 6, then minimum is 3. So at b this is the final vector that I'm getting. So if you see, there is no change at b, that is okay. Now what about at c? Now at c I will be getting some vector, let me write it here. At c I will be getting one vector. So let me I will be updating the vector. So I will be getting the vectors from three values. So from a, b, and d I will be getting the vectors. So this value is 2, this value is 1, and this value is 3, right? So from c to c is 0. So let me just compare 7, 7, 1, and 3. So 7, 2, and 3, right? So 2 is minimum, and then let me compare 5, 1, and 4. So 1 is minimum, and 8, 4, and 2. So 2 is minimum. So at c I am getting the vector 2102, which is not also updated, so that is completely fine, right? So let me remove these values now. Now let me write the value at D that I will be getting. So at D, this is the updated vector that I will be getting. So D to D is 0. Now at D I will be getting vectors from A and C. So this value is 2, this value is 7. So 7 plus 0 is 7 and 4. So 4 is minimum, right? Here 4 is minimum, and then 8 and 2 and 1 3, so 3 is minimum, and 2 and 9, so 2 is minimum. So if you see that this value from 5 it got updated to 4. So basically if you want to reach to A, then you can use this path that is having 3 edges, and you can reach to A instead of using this path which is D to C and C to A. So the final vector at D is this, and final vector A is this, final vector at B is this, final vector C is this. So these are the final vectors that I am getting. I hope you got it, right? So this is how we will be solving distance vector routing problem.